Hello to all of you and welcome back to my SP2 channel. So this is the beginning of our new chapter. We're going to be looking at all the periodic trends, starting by the effective nuclear charge, which is a kind of core concept. We're going to be looking at the periodic trends for that, and then I always have a practice for you at the end. Okay, so start by thinking about what we have in an atoms in terms of the particles, right? We have our electrons, we have the protons. So we know that the electrons are going to experience two key electrostatic forces. The first one is the proton-electron attractions, right? Which is going to be, the positive charge of the proton in our nucleus that is going to attract the electrons because they are negatively charged, right? And then I have the electron-electron repulsion, and this would be like repelling of the electrons, right? They're going to repel each other, which is going to reduce the net attractions of the nucleus. Okay. Now, this would be pretty simple if you have something like a hydrogen atom, because there's only one electron for hydrogen, right? So we don't have any like electron-electron repulsion. But for all the other elements higher than hydrogen, we're going to have more than one electron. You can call them multi-electron atoms. And the electrons are going to shield each other, which is going to reduce the nuclear attraction that other electrons are going to experience. Okay, this is going to be known as Z effective, right? So these electron-electron repulsion cancel out some of the attractions that the electrons have to the protons, right? And we're going to go by the Z effective or the effective nuclear charge. And I want you to remember this equation, Z minus S. So the Z here is presenting the total nuclear charge, right? Which is typically the number of protons. And then the S is a factor that we call that shielding factor or like shielding constant, right? And you can think about it as your core electrons, right? That would be the best way of, presenting your S value. Okay, so on the next two slides, we're going to be looking at the trends and then we have a practice for you. Okay. Okay, now we're going to be looking at the periodic trends for our Z effective. Okay, so when you are moving from the left to the right side of the table, the Z effective is going to increase. And let me tell you why. Okay, so think about your Z value, which is presenting the number of protons. And yes, we are going from left to right, so we're adding more and more protons. And therefore, the polling of the electrons are going to be closer, right? And we also have the S value here, but that would stay almost the same, right? Because the S is presenting your core electrons, right? And if you think about your electron configuration, for all of the elements that we have on the same row, the previous noble gas was presenting the core electrons, and that stays the same, right? So almost no change in the S, but Z is going up, and therefore when you take the difference, that must be increasing. Now, the story is slightly different when we go from top to the bottom down a group. Okay, we're going to have very slight change in our Z effective. Okay, so although the nucleus has more protons as you go down, the outer electrons experience less attractions due to the increased distance and slightly more shielding by the core electrons, right? But you can also say that you get more number of electrons, right? More number of core electrons. So the difference is going to be a lot smaller, okay? So we always need to consider the significant, change in our Z effective is always going to be the time that we are moving from the left to the right of the table, okay? Now, let me show you a practice. Follow me on the next page. Okay, so here's the question. What is the magnitude of Z effective for lithium and sodium atoms? So these two are in the same column, right? If I go by lithium, I'm going to have Z, which is the number of protons, and that is 3. And I have S, which is the core electrons, that's helium, right? The previous noble gas. You take the difference, it's going to be 1 plus, right? Now, if you do the same thing for sodium, we're going to get the same value, right? So you actually can see that when you go down a group, this is group 1, we don't expect to get much change in our Z effective, okay? Excellent. Thank you very much for watching this video. There are going to be a couple of more videos coming up soon, and I will see you then. Take care of yourself, and bye-bye for now.